So I would be speaking today mainly about lessons from the cloud. How do you rethink data when you move into a more cloud-native era? And Amelia spoke more about centralize. I will speak more about decentralized warehousing and why it is required to have this decentralized warehousing. Just from my background, I've been working in data for approximately over a decade. I've worked in some major banks and I've seen a lot of this transformation happening on corporate level as well. And today I will try to summarize this experience into a 30-minute presentation. So the most basic question is, why do you need to rethink everything? So one of the main features of on-premise systems was that they give you control, but there is like a limited flexibility. If you want to scale up on your hardware, you have to add machines into a specific server room. And this is why when you move over to a more cloud-native era, this part is not important at all. What is also very prominent in the on-premise structure was that your product teams, they are not responsible for their data. You can access their databases directly, and you need to model this data yourself. One of the key fundamental difference also is that your infrastructure is a fixed cost. So no matter how long you run a query, it does not matter. At the end of the day, it would take days, but you will not incur any cost on top of that. And at some point in time, your data engineering on-premise will become a bottleneck because everything is very tightly coupled with your physical infrastructure, with your DBA team, and somehow everything needs to go through a technical setup in the end. So at the end of the day, in cloud, technology is the easy part that needs to change. What is hard is the organization that you need to adopt to. Now I will speak very briefly about the architecture challenges that you face on-premise infrastructure. You have very tightly coupled systems. Everything is centralized into an SQL server setup. So this is like a typical example of a very on-premise infrastructure where everything sits together in a single server or single machine. Everything is owned end-to-end by data engineers and DBAs, and your business needs to go through these two functions to make this data available. Your product teams have no responsibility for any kind of data provision for this space. Data engineers need to model this data and then push this data into your analytical layers. In case of, if you are using an enterprise suite like Microsoft, your ETL pipelines are embedded into these suite tools. For example, in case of SQL Server, you have these integration services and you have these reporting services. Now, what is the cloud native shift and how does it differ? In cloud, you pay as you go. So the compute pretty much shapes your architecture. You need to be very mindful of who is using what and is it really worth spending the money on your compute. Secondly, your data must be curated and shared by your product teams. And this is where you decentralize the responsibility of modeling and data provisioning over to your product teams as well. Infra owns orchestration and observability. So they need to provide you some sort of a framework where you can monitor your cost, where you can govern your access as well. So infra play a more of a orchestration and observability role rather than having these physical machine and DBA's role in the team. I think the last point is that your data team focus on modeling and enablement rather than making and building these ETL pipes. So it's very important that you understand your organization as a whole and you understand how to enable your organization by providing them data. This is kind of a checklist that I try to put together. So before you go cloud, you need to do a reality check. And these are the list of things that you need to ask yourself as an organization. So first thing is, are you streaming your data via Kafka topics or via other streaming services? Or is your data still batch transformed by a central bottleneck team? Then the second point is, are you just lifting up your infrastructure or are you rethinking your whole vendor stack? One of the key distinctions is that if you are moving from a Microsoft to AWS-based services, this changes a lot of skills that your engineers need to upskill. So you need to be very mindful of what kind of vendor you are selecting for the future. Another part is your infra team actually cloud native or do they still work on tickets? So your infrastructure should act as a product, not as a ticketing service where every single request needs to go through them. In the end, if you don't take care of that, in a way that data engineering and DBAs become a bottleneck, infra will become a bottleneck for you as well. Another part is you need to have a commitment from your stakeholders. So have they actually booked a dedicated time slot to spend on this transformation, or are they just having some opinions about stuff? This part is also quite important. So is there any roadmap? Do you have any timelines? Do you have any milestone, or are you just moving along with vibes? So you need to be very clear to separate your targets than what you feel about things. And once you move into cloud, things change, things get decentralized, and you need to be very careful of who owns what. What does infrastructure own, what does product own, and what is data owning as a department as well. Then, are there any data contracts in place? Because previously there was no product responsibility for data transmission. Now you need to have this agreement with your product teams as well. And you need to make sure that there is no such bottlenecks or point of failures in your team or your department where one person holds all the knowledge, and when this person leaves, it kind of leaves you with a blank spot. Then I think this is one of the part a lot of organizations struggle with. Cloud is more sold as a tool which is cheaper, but it's more scalable in my perspective. So do you have a financial operational plan as well? Or will cloud pretty much take all the money from your wallet? And the last thing is, does your data producer know that they must now send curated data and not raw database dump? And this could take actually much longer than what you should expect, because different domains in your organization would have different maturity level on this kind of analytical and data event understanding as well. So now I will show you a bit how the legacy architecture works. By legacy, I mean pretty much the on-premise structure. So if you look at this thing, I didn't draw any arrows because once you draw arrows, things become too complicated, so I just skipped that part. For the simplicity's sake, everything is going from top to bottom. So if you look at this setup, you have your source layer, which is your producer. Inside your producers, you can have an ERP system. I just put some placeholder for SAP. Then you have some financial systems that takes care of your accounting logic as well. Then you have a centralized CRM. In most cases, it can be Salesforce or any similar tool. And then all of these applications, they have operational database on which they operate as an application. And then there are some external exchange of data within your organization or via your merchants or clients as well. If you move down, this is where we enter our data landscape now. So you have your DBA, ops, and orchestration part, where you have your integration services that integrate your external source layer with your warehousing layer. Then you have a code base. You can use TFS or any kind of enterprise solution there. Then you have your reporting services, which provides some interface for your organization to interact with this. And then you have SQL agent, which kind of takes care of your scheduling of jobs, running these batch processes inside, and this is completely owned by your DBA team. And then you have these SFTPs. Then you move one level lower, and this is where this warehouse comes in. So it's a very centralized warehouse. Everything is managed by data engineers. You have a big storage area, which store your code as well as your files as well. Then you have your stored procedures, which transform this data where your ETLs are happening. And then you have these analytical marts. It could be data mart or whichever modeling you are following. And then you might also have some .NET application to transform any non-CSV related files, for example, JSON. And then you reach your BI layer. So if you look at this flow, everything follows a very well-defined pattern, and everything is centralized in your monolithic warehouse. Now, I will move forward to how do you decentralize your architecture. So this is how it looks like in cloud. You can replace these tools by other, I'm just using these placeholders. So you have your source layer, similar topics. One difference that you see now is there are product services and APIs. And this is where your product is supposed to give you curated data sets in form of JSON streaming or any kind of Kafka streaming that you have. Then your DBA got replaced by a platform layer. You can also call it an infrastructure layer as well. This is the layer where you take care of your workflows. You can use Airflow, or you can also use Dexter, as you saw. And then you have your repository, which is usually Git or Bitbucket or any kind of these tooling. Then you have these domain events. And these are the events that are transmitted not by the operational databases, but by your product teams as well. And then you have your deployment pipeline. Jenkins is one of the example. And you can also include a compute engine if your organization is a bit mindful of having these managed platforms like Snowflake. Then you move one level lower, and this is where you have your storage layer. AWS is one of the solutions that you can use, and within this storage layer, you have these different buckets of data, where you store your domain as a separate bucket to have this kind of separation between data and to have stronger data governance as well. And then you can also build your export products that can act as an interface with external consumers as well. Now, if you move one level lower, I divided this part into two warehouses because I come from a very regulated fintech and insurtech setup. So there you have to have a very strong observability, governance, and auditability as well. So if you look on the left side, this is where your analytical warehouse sits. So this layer, this warehouse, in this case, it's Snowflake. You have your curated data set that gets into from your source layer to your storage and then inside your analytical warehouse. And this is where you need to pay for your computation. And you need to be careful what you push, why you push, and who needs it for which value generation. Then you have your semantic layer, which you already saw, which is a DBT where you model your data into different schemas and you define how exactly your modeling of data would look like. You move one level lower and you reach your data products. One of the key differences that you see here is there are multiple data marts, and each of these data marts are important for different domains at the end of the day. So for example, your financial team can have a different data mart, your commercial team can operate with completely different data. And because of having this unlimited compute, you can generate these data marts on the go, and you can scale quite fast on that. But you need to be careful about what is the final value add that this data or this data mart is providing to you. And then ML or insights also sit within your analytical warehouse, or you can put it in your compute engine as well, if your organization is very cost sensitive in this case. On the right-hand side, you see this financial warehouse. Most of the financial company, they work with SAP data, and BW is kind of this most used tool. It's a bit of an old-fashioned one, but it does the job. On the financial warehouse side, your accounting, your controlling teams, they love working with Excel, and this is one of the tools that BW offer as an example in your financial warehouse. Then you have these multi-dimensional cubes that can pull this data into Excel, and it can be modeled as they want. So this gives you a lot of flexibility on combining these multi-dimensional data sets in a tool like Excel. This is also where your taxation sits in, or any kind of critical financial reporting that requires a high accuracy of data as well. These two warehouses can also connect with each other, and you can use your staging layer for these two warehouses to interact with each other. Then at the very end, you have your BI layer, and this is where your business intelligence is sitting. This BI layer usually uses Tableau or any kind of modeling KPI-driven tool that you are using, and you keep a KPI registry in there. So for example, what kind of KPIs your commercial team is driving, and you implement those KPIs within this dashboarding tool. This BI layer can connect to both analytical and to financial warehouses, but based on the experience that I have, the tooling, BI tools are way more compatible with the analytical warehouse. And this is why sometimes it's a bit more important to analyze this use case very in depth as well, where you bring your financial data inside your analytical warehouse to have this seamless connectivity between these two cloud native tools as well. So I think this is where I felt like I need to give a bit more understanding on how does the ownership shift versus the old and the new part that you saw. So on-premise model, your DBA and your data engineer, they have it all. So they model your data, they take care of your server, and they control pretty much everything when it comes to ETL or pipeline development. This is a very bottleneck, centralized approach, but when you move into a cloud-native model, your product teams, they own data generation. They take ownership of the quality of this data. They take ownership of this event-driven aspect of this data as well. Your infrastructure now own performance, reliability, and cost. They need to provide you tooling where you can monitor your cost, because the more you spend on compute, the more money you pay. And there is no initial cost. You pay as you go. So your infrastructure also play a key role in enabling you to see where you are spending what kind of money. And then you have your data teams, and the role of data teams move a bit away from these ETL development to enablement, reuse, and semantics. And this is where you need to derive value from this data to enable your business to make better decisions based on a cleaner and more auditable structure of data as well. So at the end of the day, if you have to take away some strategic takeaways, my suggestion would be push the ownership of data production to your producer domain, beginning of your migration process. Treat infrastructure as a product, not as a service. So for example, when you use tooling like Snowflake, you don't create tickets for them. They provide you a product and you can customize this product the way you want. And that's how an organization should also treat infrastructure as well. When it comes to managed services, so what do I mean by managed services? These are the platforms like Snowflake that are hosted independently, and you don't need to take care of these services. They provide you everything within and a user interface as well. They are very good for the enablement of your business, but if you don't architect these warehouses properly, they can explode a bit on the cost side as well. So have a good FinOp plan so that you don't run out of money early in the process of migration. And I think one of the key factor is that you need to design for reuse, not for control. So whatever you create in a cloud native era, it has to be reusable across multiple domains that you have. Your governance, like if you look at this architecture that I presented, you have multiple warehouse, who access what, this becomes very important. And every organization evolve in this architecture based on how they are organized or how they operate on their business side as well. So governance, especially in sectors like fintech and insurtech, is quite important because of the audits. So you must evolve your governance as well with your architecture. And yeah, that was all from my side. And feel free to connect. This is my LinkedIn, and happy to take some questions.